Okay. Obligatory notices. Okay, so in forensics, you want the ability to repeat what you've done, or somebody else can repeat what you've done to be able to prove that there were no steps missed or skipped on purpose. That's the repeatability factor that needs to happen during digital forensics as well as traditional forensics, right? Should be repeatable at a later time if they need to do so. That same exact data that you discover or the information that you get should be able to be repeated using that exact same process. For an example, malware discovered in the C Windows System32 folder using hash analysis. If another examiner goes in after the fact and runs that same exact process, they should be able to find that same malware in the same location. This is so the shady part of, I say the shady part, but the courts require, right, exact things. So if they're slightly off, these things can be thrown out of court. So it's very important that the repeatability portion of excuse me, forensics is followed carefully. Okay, verifiability. It's kind of a funny word. When we're talking about verifying evidence, in this case digital evidence, we're essentially talking about hash values, right? Taking a, say unknown, but a different value of characters or numbers and running it through a function and getting a standard set of values back. So in evidence, they use this, or I should say in digital evidence, they use this all the time to prove that what you copied from what was there on the drive is the same exact thing that you have that you're working on. And again, to prove that there's nothing that's been changed, and in particular purposefully changed about what you've been working on. Right? And kind of a better definition might be a hash value is a resulting character string of a one-way mathematical algorithm calculated against a given data set. Perhaps you've heard of the MD5 hash, or the SHA-1 or the SHA-256 has come up now. The key to this is hashing, if you think about it, is a one-way encryption. You use what it is that comes out of it. Encryption in general, when you talk about encrypting something, you decrypt it to get it back to its clear text state. When you use hashes, you use the hash value to verify what it is. And this is what they use as a function. Like I said, the MD5 hash puts out a 40-byte character string at the end of it. Some of them are as long as 140 bytes. The key to hashes is collisions. So you don't want multiple values going in coming out with the same value coming out, correct? That makes sense? If you put in, let's just say ABC, and you come out with XYZ as the answer, if somewhere down the line STU also comes out with XYZ, now you have a problem because you can't prove which one did you actually put in. Did you put ABC in, or did you put in the STU? Does that make sense for hashing? Okay. I don't know how much you're familiar with the hashing process, but collisions are the main issue with hashing, in that you don't want obviously information coming out that you cannot verify what actually went into the system. So that's why they're becoming bigger and bigger, so your data sets can become bigger and there won't be as many collisions, or hopefully no collisions at all when you're working with them. So like it says, examiners should always work on a forensic copy. This is a best practice of the evidence, not the original evidence. This seems really obvious, but sometimes people do work on the actual hard drives. And then if they mess anything up, of course, that means your data is no longer any good.